right, so let's take a look at number 13. So they give us this set A and this set B, and they want to know what is A or B, okay, the union of set A and set B. So remember, when we see or, right, or tells us that we need to include everything. Okay, so if you see it in set A, you need to include it. If you see it in set B, you need to include it. Even if it's overlap, see how there's like a 6 in both sets? You're still going to include the 6. All right, so if you look at choice 4, look at this, choice 4, every component of choice 4 is found either in set A or set B or both. Okay, so choice 4 is going to be our answer. Okay, number 14, a fair 6-sided die is rolled 3 times. Let A be the event that at least one of the rolls is a 6. Okay, they want to know what represents, this little symbol right here means a complement, okay, the complement of A. All right, now if you guys recall, right, the complement just means, you can think about the word not. It means what is not in set A. Okay, so if A represents the event that at least one of the rolls is a 6, then the complement would be that none of the rolls is a 6. So that would be choice 2. Okay, so now number 15. Juan and Felipe practice at the driving range before playing golf. The number of wins and corresponding practice times for each player are shown in the table below. Okay, so this first part here says, given the practice time was long, okay, so we're given long, we have to determine the exact probability that Felipe wins the next match. Okay, so we're finding the probability. Now I'm going to actually, since they put the word given first, right? Let's think about this. Doesn't this symbol mean given? So we're given long. We want to know what's the probability that Felipe wins. So we're finding the probability of Felipe given long. Okay, so if we're given long, let's think about it. All right, so this right here represents the long practice time. So we're really only thinking about these numbers. Now we haven't totaled this out, so we might as well total this out, right? So 15 plus 12 is 27. Okay, so since that's the total of the long practice time, right? Since we're given long, that is going to be our denominator. And out of those 27 long practice times, how many times does Felipe win? Well, look at this. Felipe wins 12 of those times, so 12 out of 27. Okay, and then on the bottom here, it says that they want us to determine whether or not the two events, Felipe wins and long practice time, are independent. Okay, you know what? I'm going to go through, I want to total this all out. So we're talking about Felipe wins, so I'm going to put an F there, and long practice time here. And let me just total everything out. So Juan wins 23 times, Felipe wins 22 times. Short practice, 8 plus 10 would be 18. We've already summed up this row. And if you add everything together, right, whether you add 23 and 22 or whether you add 18 and 27, that's going to give you 45. All right, now, there's 2 different methods that we can use for independence. Okay, the first one, I'll call that method 1. That's the one that we use, I think, more often than the other. Although some of you like method 2 better, and that's fine. You could use whichever one you like. So a lot of you use this rule. And if you note, I put a question mark on top, right here, because we don't know if this rule is going to work or not. The other rule that you could use, and we'll call that method 2, is this rule. And the reason why this rule is probably easier for this one is because, look, didn't we already find the probability of Felipe given long over here? Let me start with method 2. Okay, so we already know the probability of Felipe given long is 12 over 27. So I'm just going to plug that in. Okay, and then over here, the probability of Felipe winning. Okay, well, Felipe wins 22 times out of the 45 total matches. So 22 out of 45. Okay, some of you will be able to see that these two are not equal to each other without even really doing anything else. But let's see, 12 over 27, that simplifies to 4/9, right? Divide the top and bottom by 3. Whereas 22 over 45 does not even simplify. So these two fractions are not equivalent. So we can say the two events are not independent. Okay, I'm going to write that in a minute. Let me just go over to method 1. So with method 1, we want to find first the probability of Felipe and long practice time. So if we look up here, 12 times is when Felipe wins and there's a long practice time. And that's out of the 45 total matches, so 12 out of 45. And then over here, the probability that Felipe wins, well, Felipe wins 22 times out of 45. And then times the probability of a long practice, well, there's 27 long practices out of the 45. Okay, so if we multiply together 22 over 45 and 27 over 45 in simplest form, that is 22 over 75. Whereas this simplifies to 4 over 15. So again, they're not equivalent to each other. So we can say that the two events are not independent. Okay, so you can just write that out. You don't have to give an explanation because your work, whether you use method 1 or method 2, shows why they're not independent. Okay, neither formula for independence worked. All right, number 16. So it says, Joette is playing a carnival game. To win a prize, one has to correctly guess which of the 5 equally sized regions the spinner will land on, as shown in the diagram below. She complains the game is unfair because her favorite number 2 has only been spun once in 10 times she played the game. Okay, so this first part says, state the proportion of 2s that were spun. Well, it was spun 1 out of 10 times, so the answer to that would just be 1 out of 10. If you prefer to write that as a decimal, that would just be 0.10 or even 0.1, right? So either one of those, I'll say or is fine. Now down here it says state the theoretical probability of spinning a 2. All right, well, let's see. There's 5 equally sized sections, and one of them is a 2. So the chances of landing on a 2 would be this one space out of these 5 spaces. So 1 out of 5. And if you prefer to write that as a decimal, that would be 0.2. Okay, so either answer is fine. You don't have to do the fraction and the decimal, just one or the other. All right, the simulation output below shows the results of simulating 10 spins of a fair spinner. Okay, and it was repeated 100 times. Does the output indicate that the carnival game was unfair? Explain your answer. All right, so if we look, I'm going to just go back up here, right? With the carnival game, they only spun a 2, 1 in 10 times, so 1 out of 10, which we said is equal to 0.1. Or if we look down here at the simulation, wouldn't this be the 0.1? I'm going to actually circle that whole column. This is the number of times out of the 100 simulations that 1, 2 out of 10 spins occurred, right? It occurred 10% of the spins, so 1 out of 10. Okay, so does the output indicate that the carnival game was unfair? Explain your answer. I would say it does not indicate that the carnival game was unfair because look how many times only 1, 2 occurred. It occurred, I mean, you can count this, but even if you look up, see where 20, it looks like 21 times. You can count them if you want, but it looks like it occurred at least 20 out of the 100 spins. So that's 20% of the time. So that's considered a normal, usual occurrence. So no, I would not say that it was unfair. Okay, so no, because 0.10 occurred over 20% of the time, making it a normal, expected, usual occurrence. All right, number 17. Which relationship can best be described as causal? Okay, so I'm just going to underline that word right there. Sorry. A causal relationship occurs when one event directly makes another event happen. Okay, so if you look through these answer choices, it appears that choice 3 is definitely the causal relationship, right? It says the more hours a TV is on, the more electricity is used. Okay, so the TV being on is causing the electricity to be used. So choice 3 is going to be the answer. Choices 1, 2, and 4, they might show some sort of correlation, but one event is not directly causing the other event. So for example, just because someone is taller, it's not causing them to have, a higher intelligence. Okay, choice 3 is the only one that shows a causal event. All right, number 18. A study found that as the average daily temperature increased during the summer, the amount of ice cream sold at a beachside stand also increased. Okay, so these two events definitely have a positive correlation, right? So I'm going to cross off choice 2 and 4. And although they do have a correlation, it's not a causal relationship. Just because the temperature is increasing, that's not what's causing the amount of ice cream, sales to increase. Hot weather, although it might encourage people to buy ice cream, it's not forcing the sale to happen. It's not the reason why the sale is happening, okay? It could be other factors as well. Usually when it's hotter out, right, there's more people at the beach, and more people means there's going to be more ice cream sold. So although it has a positive correlation, one event, the increase in temperature, is not causing the other event to happen, okay? The increased temperature is not forcing people to buy ice cream. There's other factors that go into play. So this would be choice 3. Okay, number 19. To determine if the citizens of a town would support a tax increase to build a new public swimming pool, a local reporter interviewed the first 50 people leaving the town's private fitness club on a Saturday morning. Explain the statistical bias in this method of data collection. All right, well, really, I think the main one is he only surveyed people leaving a fitness club. And if you think about it, that's a specific group of people. That's people who are interested in fitness. So their opinions might not represent the opinions of the town's population as a whole. Okay, so I just wrote that out. By only interviewing people leaving a fitness club, the local reporter is only sampling a specific group of people who are most likely interested in fitness. This specific group's opinions may not represent the opinions of the town's population as a whole. Okay, number 20. A local news station conducted a phone survey of 500 registered voters to gauge opinions on a New York City park initiative. Participants were randomly selected from public voter records. The results showed that 60% of those surveyed supported the initiative. State one possible conclusion that could be made about the population of registered voters based on the survey. Okay, so usually why they take a survey of a sample of people is so that they can make a conclusion about the population as a whole. So, I would say that since the results showed that 60% of those surveyed supported the initiative, really what that means is they can conclude that 60% of all registered voters in the city would also support the initiative. Okay, so again, since 60% of those surveyed supported the initiative, one possible conclusion is that 60% of all registered voters in the city will support the initiative. Okay, and that's why you take a survey of a sample to make conclusions about the population as a whole.